Welcome to the next session of hypothesis testing. In the last session we started hypothesis testing and we had covered two tests under large samples. We discussed single mean and difference of means. I hope you all remember that. The procedure would be same, like hypothesis testing here means we would like to test our assumptions about the population parameter. What are assumptions we make under null hypothesis and the alternative under alternative hypothesis. Then under those assumptions the procedure would be same, that is we will have a certain level of significance, we will define alpha value and then we will have the test statistic z, and once we have the test statistic z which we call z calculated, that z calculated will compare with the critical values at certain level of significance that we already defined, which is alpha, and then if it falls under the critical region, means it goes outside the boundaries of the critical value of z, then we will have to reject H naught, that is we will go by the assumption under alternative hypothesis, and if it falls within the boundaries of that critical region, then we do not reject H naught. So, we cannot conclude whether H1 is true or not. So, moving further, in total we have 7 tests, 2 we have covered, 5 more we will try to cover today. There are 4 tests under large samples, there are 3 tests under under small sample test. Under small sample test again we would be having single mean, difference of means. So, this would be quite similar to the large samples. The only difference would be that since these are small sample in size, then these may not follow, this will not certainly follow the normal distribution properties. So, we will have to have a different test which we call a t test. Then the last situation can be pair t test, that is the case of dependent variables. Till now first 6 tests are under independent variables, that there is no association between one sample the another sample, whereas in pair t test there would be a dependence, an association between 2 samples. We will have this in detail when we will come to that topic, that part in pair t test. So, after single mean and single proportion, we are moving to difference of means. Under difference of means, our test statistic would be, I am skipping the other steps, that is define null and alternative hypothesis, have the level of significance, then comparison, that is understood. Any hypothesis testing will have to follow all those steps. The only difference will come because of the test statistic under different situation. For difference between 2 means, so the situation is there is one sample having a mean x bar a, another sample having sample mean x bar b. So, here we would like to test whether both these samples represents the same population, whether these have been drawn from the same population. So, if they are drawn from the same population, their averages should be equal. The population mean mu a bar should be equals to population mean mu b bar. So, our z here would be x a bar minus x b bar by the standard error of x a bar minus x b bar. So, we used to divide by standard error. So, this s represents the standard error here. So, how do we define that standard error for difference of means? That is s square a, the standard deviation of a. So, this will be variance a, variance b by number, the sample size for a, sample size for b, the whole under root. So, once you have the standard error, you can use that in the test statistic z. So, that will give you z cal. We will have to compare that z cal with z tabulated obviously, and then I hope you remember at 5% it was 1.96, at 1% it was 2.58. So, just a comparison is needed. If z cal is less than z tab absolute value, then we consider that in the acceptance region. If z cal is absolute value is more than z tab, we consider that in the critical region, and accordingly we accept or reject the hypothesis. Here are some questions. So, the issue would be, because there are 7 tests under hypothesis testing, the first challenge would be to identify the situation under which test it belongs to. So, my suggestion here would be that while reading the particular question or particular situation, I would recommend that you extract all the numerical values given and then see to which situation it belongs to. Say if we have this first example, there are two machines, machine A and machine B produces identical components, and it is required to test if mean diameter of the component is same, right. Both the production of machine A and B, the diameter is same or not. A random sample of 144 from machine A had a mean of 36.4 mm and standard deviation of 3.6 mm, while a random sample of 225 from machine B had a mean of 36.9 and standard deviation of 2.9. So, what information is given? There is a random sample of size 144, another random sample of size 225. Two random samples are given, both are greater than 30, right. So, this will come under large sample obviously. Then we are given average of first sample, we are given average of another sample. So, two averages are given. The question is, are the means significantly different? So, two averages are given, obviously it is a situation of difference of mean, whether if they are equal, so there is no difference. If they are not equal, there is certainly a significant difference that we need to test. So, you are given the averages, you are given the standard deviation. I hope you can calculate this Z also. Another question to understand how to identify: a machine put out 20 imperfect items in a sample of 500. After machine was overhauled, it puts 5 imperfect items in a sample of 150. So, now again there are two samples. So, again you can apply the difference of, rather here there is one important thing. We are not given the averages, this is a certain kind of characteristic out of the sample. So, this is one proportion is given. Okay. Then another situation, there is a sample of 150, but this is not the sample mean, it is not the average. So, 20 out of 500 is the proportion before overhauling the machine, and 5 out of 150 is the proportion after machine is overhauled. So, in this case, this is not a situation of difference of mean, this becomes a situation of difference of proportions. So, we will consider this under difference of proportions, and under difference of proportions, you remember the standard deviation would be PQ by N under the root. So, you can use P1 Q1 by N1 plus P2 Q2 by N2 whole under root, that will be the standard error, and Z would be P1 minus P2. So, hope you can apply that here, the Z formula in terms of P1 minus P2. P1 is 20 by 500, P2 is 5 by 150, and standard error would become P1 Q1. So, P1 is 20 by 500, the Q1 would be 480 by 500, and by N1, N1 is 500, then P2 Q2 in terms of 5 by 150, and then 145 by 150, N2 here would be 150, right. So, the basic difference is only of the test statistic, rest the complete procedure is same. That can bring a good feeling to you. Once you are able to understand this, the rest whole procedure is same, and that will help you in having a conclusion or a right kind of interpretation, whether we should go by the null hypothesis assumption or alternative one. There is another question here. In order to make a survey of the buying habits, two markets A and B are chosen at different parts of a city. To understand the buying habits, we have market A, we have market B. From first market we collect a sample of 400, from another market also we collect a sample of 400. So, we have average for first market 250, for another market 220. The standard deviation for first is 40, standard deviation for second is 55, and Xi represents the average weekly expenditure. So, average weekly expenditure, say it is 250, in terms of another say it is 220. Test at 5% level of significance whether the average weekly food expenditure of two population of shoppers is equal. So, which situation it is? Is he saying that we need to compare the single sample with the population? He is not saying so. right. He is also not talking in terms of proportion, he is only talking in terms of means. There are two means, their difference we are talking about. So, it is a situation of difference of means, right. Hope you can solve this with the same z value. And then one more, suppose company wants to know the rating of their brands in two different cities, say Delhi and Bombay, is same or not. Survey was conducted in two cities and rating was collected on a scale of 1 to 10, 1 poor, 10 excellent. The data was collected from 50 people in each city. Average rating on interval scale is same as in Bombay or different. So, again there are two cities, averages of two cities is being considered in situation. So, whether those averages are same or not, that is the issue. So, this will also be a situation of difference of means. Another question here, maybe let us try to solve this. Can we conclude using alpha as 1% that the mean driving distance of par inclusive golf ball is greater than the mean driving distance of RAP limited golf ball. So, there are two kinds of golf ball available, of par and of RAP. The sample size for par is 120 balls. They have considered how distance they travel, and of RAP 80 ball sample size they have taken of how much distance they travel. Sample mean for first is 275 yards, that ball is travelling, another is 80 balls, sorry 258 yards, another is travelling. So, the question is based on data from this, this also information is given that the standard deviation is sigma 1 and sigma 2. The question is in the beginning itself whether the mean driving distance of par, which is 275, is this greater than the mean driving distance of RAP. Can we consider this to be significantly more than of RAP limited, right. So, all the information is given. So, how to handle it? We can develop the hypothesis. You can say for RAP it is mu 1, and say for par it is mu 1, and for RAP it is mu 2. Par is here mu 1, sample number 1, RAP is 2, sample number 2. So, there are two ways. One, we can say mu 1 is greater than equals to mu 2, right, and another mu 1 greater than mu 2, that will be alternative hypothesis, and mu 1 is less than equals to mu 2. What is his requirement? He wants us to help in concluding whether the par inclusive golf ball is travelling a greater distance than RAP limited. Okay. So, if it is travelling a lesser distance, means it is the another situation than travelling a greater distance. So, we can say in the first null hypothesis that it is less than mu 1 is less than equals to mu 2. Either here you can say mu 1 is equals to mu 2 or less than equals to mu 2. This is the null hypothesis of equality. Then alternative will say mu 1 is greater than mu 2. So, the par inclusive is able to travel more distance than RAP limited. This defining the hypothesis is very important. So, we need to be very careful, and the hint here is that equality sign will always come under the null hypothesis. Null hypothesis means no difference, right. So, even if you are not taking this lesser sign here, that is fine, mu 1 is equals to mu 2 and mu 1 greater than mu 2. It is understood if it is not mu 1 greater than mu 2, either it is equal or less. So, we are not concluding this, we are concluding otherwise. Okay. Level of significance given is 0.01. Then from another we will take x1 bar minus x2 bar. This D0 is means their average population, they are drawn from the same population. So, population means would be equal, mu 1 bar equals to mu 2 bar. So, this will automatically be 0 here. Then x1 bar, x2 bar are given. X1 bar is 275, x2 bar is 258. Then their standard deviations are given. Use those standard deviations here. Then sample size also use these averages, and you will get Z calculated. So, using the same procedure, first step of defining the hypothesis, second defining the level of significance, then we have reached the third step of computing the test statistic. So, here in this way we compute the test. This would be the major difference between all the tests. So, you must keep this in mind, how we define Z under different situations. There are certain similarities, but there are some differences also. You must keep in mind what are the similarities and what are the differences, so that there is no confusion, there is no error while writing this and also while calculating. Then, since this is 6.49, level of significance was 1%. So, we will now write Z tabulated at 1% level of significance. If you look into the normal distribution table, we discussed this in last class also. At 1% level of significance, the Z value, Z tabulated value is 2.58. So, Z cal 6.49, Z tab 2.58, which one is larger? Z cal is larger, right? And when Z cal is larger, we will reject the null hypothesis, we will go by the alternative hypothesis, right. So, we reject H naught, we are going by H A alternative. So, what is the conclusion here? At 0.01 level of significance, the sample evidence indicate that the mean driving distance of par inclusive golf ball is greater than mean driving distance of wrap limited golf ball. So, that proves the alternative hypothesis, right. There is an evidence available from the sample, and that evidence indicates the conclusion of alternative hypothesis. Hope this is clear to you. Then we have now covered the third test, right, out of the 4 large sample tests: single mean, single proportion, difference of means we have covered. Now, moving to difference of proportions. Hypothesis testing about proportions difference. Like one question there we discussed overhauling case. So, it is a similar situation, either you can do that overhauling before service, before overhauling how many defective items that machine was producing, how many defective items after overhauling the machine is producing. So, there also you can apply this, but now we can have a look at this question. Market Research Associates is conducting research to evaluate the effectiveness of a client's new advertising campaign. They would like to see the effectiveness of a new advertising campaign. Before the new campaign began, a telephone survey of 150 households in the test market area showed 60 households aware of the client's product. Say you have certain product in the market, how many, what is the percentage or what is the proportion of awareness of your product in the market. So, before that campaign started, the awareness is 60 out of 150 as per this survey. The new campaign has been initiated. So, they have initiated that campaign with television, with newspaper, advertisement running for 3 weeks. So, they did this for 3 weeks. A survey conducted immediately after the new campaign. So, once that campaign is over, now you conduct a survey of awareness of your product. So, now you take a sample of 250 and 120 show that they are aware of the client's product. Does the data support the position that advertising campaign has provided an increased awareness of client's product? So, with the advertising, whether the awareness increased or not, that we need to decide. So, again the same situation here, we will try to extract whatever numerical information is given to us. The first information given is 60 out of 150. 60 out of 150 information is P1. This is the proportion of awareness before the advertising campaign. So, Q1 would be 150 minus 60 means 90 by 150 and N1 is 150. Then after that campaign, your P2 proportion of awareness here is 120 and out of N is 250. So, Q2 would be 130, 120 into 130 by 250, that would be P2 Q2 by N2. So, I hope you can handle it. So, please try. How do you try the marketing research associate in deciding whether the awareness has been increased due to that advertisement in television and newspaper. So, process we have to follow the same process. We will define the hypothesis. The hypothesis one way is keep P1 is equals to P2. Again, whether you write in this form, P1 was before advertising campaign, and here we try to consider both the situations, that because of television and newspaper it has gone down, although chances of that are very low. So, even if you miss this not less than sign, just consider equal to sign, then also it is fine. Then in alternative P1 is greater than P2, that P1 here is after the new campaign. After the new campaign, the awareness, the number of proportion is increased. So, here please consider after campaign as P1 and before campaign as P2. So, in the first case you can consider that there is no change. In the second case, you are assuming as an alternative hypothesis that the proportion of awareness is increased. So, same you will define the level of significance here, and level of significance say is 5%. Under that level of significance, we define P bar as this is N1 P1 plus N2 P2 by N1 plus N2, and the standard error would be this is P1 Q1 into 1 by N1 plus 1 by N2, right. So, and Z would be P1 minus P2 by standard error. You can please keep this in mind. P bar in the standard error would be using this P bar value, the combined proportion of both P1 Q1, this is sorry N1 and this is your P1 N2 P2 by N1 plus N2. P bar is this, and then Q bar would be 0.55, then the standard error of the difference would be 0.0514, and Z value would be P1 minus P2 by the standard error. So, here the Z value comes out to be 1.56, and we will compare this with the critical value. Since it is a one tailed test, we will only talk about the acceptance. We are only talking about whether the awareness has increased or it is the same. So, at 5% Z critical value is 1.645, and our calculated is lesser than this 1. So, we cannot reject H naught. Hence, here in this case we cannot conclude that the proportion of households awareness of the client's product increased after the new campaign. There might be a marginal increase, but we cannot conclude that there is a significant increase in the proportion of households awareness of their product, right. So, in this way we can consider a situation of hypothesis testing for difference of proportions also. So, till now we have studied difference of means and difference of proportions. So, we have covered hypothesis testing for large samples. We have covered 4 tests till now. So, to have a quick understanding, we have covered these 4 tests: single mean, difference of mean, single proportion and difference of proportion, right. Moving further, we will be taking up single mean under small sample test, difference of mean. We will also pick pair t test also, right. So, and what is a small sample test? Like it was written there, small sample test, where the sample size is small, sample size is less than 30, then the sampling distribution cannot be normal. Sampling distribution of the statistic will be far from normality. The normal tests cannot be applied here. So, we will apply exact sample test in such situations. There are certain assumptions that we take. The assumptions include the parent population from which the sample drawn is normally distributed, sample drawn is random and independent of each other. So, even if the sample size is small and sample is not normal, because it is very small, it cannot follow a normal distribution. We have the assumption from that at least the population was normally distributed, and the samples are drawn are independent of each other under random sampling. So, again rest all the things of hypothesis testing would be same. The only difference that will take place here would be of the test statistic. The test statistic here, it is t test, not the z test for large samples, t test for small samples. Here t test would be for single mean, whether that single sample is representing the population mean or not. So, under that single mean, t calculated would be x bar minus mu by s by under root n minus 1. Most of the time we have capital S given the standard deviation of the samples available with us. So, we consider this x bar minus mu by s by root n, as it follows t distribution with n minus 1 degrees of freedom. And minus degrees of freedom here is important, like we discussed in last class also. Degrees of freedom means how many values are free to take any observation, how many variables are free to take any observations. Say if you have 5 variables and their average is given, if there are 5 variables, 5 observations x1, x2, x3, x4 and x5, their average is 5. So, any 4 observations are free to take any value, right. So, if 4 observations are free to take any value, you can assume any value of those 4 observations, x1, x2, x3, x4, and fifth will automatically take such a value that the total is 25. Total of 5 observations should be 25 for the average to be 5, right. So, in this way we understand whenever there are n observations given, the degree of freedom for the mean case would be n minus 1. Some questions to understand this, that first how to identify whether it would be a t test, and then to apply this. Question is, a soap manufacturing unit was distributing a particular brand of soap through a large number of retail shops. Before a high advertisement campaign, the mean sale per week was 140 dozens. After the campaign, a sample of 26 shops was taken and the mean sales was found to be 147 dozens with standard deviation 16. Can you consider the advertisement effective? Now, if you look at this situation, before the advertisement, the mean sales per show was 140. What does that mean? Is he saying this mean sales per week was out of any sample, or it was in general? It was in general, because it was in total, rather it was in total. So, it means, was it the sample mean before the advertisement given, or is it the population mean or sample mean? And if you look at after the campaign, a sample is drawn. Before the campaign, no sample is drawn, the exact data, the total data gives the mean sales 140 dozens. So, hence this is the mu value given of the population, and then only one sample is drawn. And what is the sample size? Sample size is 26. So, it satisfies two situations. One means there is only one sample, and another, that sample is less than 30. One sample means we will have to apply single mean test. That single mean test should be under large sample, or that should be under small sample. That single mean test should be now here in this situation under small samples, because n is 26. So, n is 26, average is 147, and standard deviation is also given to be 16. So, our null hypothesis would be that H naught, what is his requirement? Can you consider the advertisement effective? So, advertisement would be effective only if the weekly sales are increased. Advertisement objective behind advertisement is there should be increase, some push in the sales. So, null hypothesis here you can either define in this form, H naught mu is equals to 140 or mu is less than or equals to 140, means it has gone down, not increased. Alternative, that it has increased, right. So, increase will come under alternative, and just equal to sign or less than equal to sign with equality obviously will come under the null hypothesis. Are given the level of significance. Level of significance is not given here in the data. So, we consider a general level of significance. In general, we consider 5%, 5% level of significance. So, you can assume that in the third step level of significance is alpha, then we will have test statistic T. So, test statistic would be S by capital S by root n. So, this is S by root n minus 1 here, capital S like in previous case we are not defining that capital S here. So, we can take sample standard deviation by root n minus 1. So, this will be 16 by 25 x bar mu you are given, and that gives you T calculated as 2.19, that is T calculated with 25 degrees of freedom. Okay. And is it a two tail test or one tail test? Two tail test or one tail test, we can decide that with the help of only the alternative hypothesis. So, in the alternative hypothesis you have a greater than sign, we are only interested whether it has increased or not. We are not saying whether the sales are now different, we are not interested in if the sales have gone down, because we are only requiring that sales should, the objective was sales should go up. So, we would like to see whether these have gone up or not. Therefore, this is one tail test and right tail test. So, T calculated is 2.19, we would like to compare this T calculated at 5% level of significance with 25 degrees of freedom with the tabulated value. If you look into the T table at 5%, the value is 1.708. Please do verify whether this is coming 1.708 in the T table given in the end of the book. So, T critical value is 1.708, calculated value is 2.19, calculated value is larger than 1.708. So, calculated goes in the goes outside the critical boundary. When it goes outside the critical boundary, what happens? We will reject H naught, will go by H 1. So, what does H 1 says? That mu has greater than 140. So, this is significant, hence the increase in sales cannot be. So, I mean to understand this, because now there is an increase in sales, we are saying that either you can directly say, can we consider the advertisement effective? It is sufficient also to write that the advertisement is effective. To have better understanding of the conclusion, we can write like this: increase in sales is not because of sampling fluctuation, because sometimes sample maybe if you take a small sample and the another sample, there may be slight variation. So, this slight variation is not because of the sampling, this is actually because of the advertisement. So, the advertisement has been effective in increasing the weekly sales, right. Always your answer, the conclusion must be in response of the requirement. His requirement was whether to conclude to consider the advertisement effective or not. So, you must write the advertisement was effective. Another question, this is also similar type, please give it a try. Here we talk about the mean weekly sales of chocolate bar in a candy store. It was 163 bars per store. So, this was 146.3 bars per store, right. Again, is it out of any sample or it is in total or in general? So, this is in total, in general, it is not out of a sample. So, this is the population parameter, population mean is given. After an advertisement campaign, mean weekly sales in 22 stores for a typical week increased to 153.7 and showed a standard deviation of 17.2. Again, it is a similar situation like previous question. N here is 22, n is less than 30, n is less than 30, it is a small sample test, and information is given about the population, information is given about a single sample. So, we have to apply single sample mean test for small samples. So, again was the advertisement campaign successful? My recommendation is that you simultaneously pick a copy and pen and try it yourself, right. H naught mu is equals to 146, that is the difference between mu and the sample mean is not significant. H naught mu has increased, is now more than 146.3. So, again his requirement is whether the advertisement is successful. So, it is effective, successful, it is one tail test, right tail test, and alpha you will take since it is not given 5%. T value again you can calculate x bar minus mu by s by root n minus 1, follows a t distribution with the sample size is 22, 21 degrees of freedom. So, the t value you can calculate. My recommendation is that you just pause it here and calculate yourself and later on verify whether you are able to reach the same value, you are able to follow the same procedure without any support. If you are able to do that, you will feel confident you can handle such questions independently later on also. So, the tabulated value, once we have t calculated 1.97, we will look at the tabulated value from the table at 21 degrees of freedom, 5% level of significance is 1.721. So, you compare 1.721 and 1.97, which is larger, this is t cal is larger. So, this is larger, then we will reject H naught, this value is significant, hence the advertisement campaign was successful in promoting sales, right. So, that would be our conclusion. So, we have now taken t test for single mean, single mean is covered, small sample size, and single sample we were comparing this with the population. Now, moving to difference of mean under small sample test, t test for difference of mean. So, we will be having two samples, both the samples would be small here, would be less than 30. So, they will follow the degrees of freedom n 1 plus n 2 minus 2, right. And in some extreme situation you may notice that n 1 and n 2 are both less than 30, but when you total n 1 plus n 2 minus 2, this crosses 30 value. The moment say n 1 is 17, n 2 is also 17, then n 1 plus n 2 34 minus 2 becomes 32. So, it follows with 32 degrees of freedom. In that case, the moment it crosses 30 value, so you can say the critical value you will compare would be a z value. This you will follow as it is for calculations, t calculated, you will compare that with z critical value, which is at 5% 1.96 and so on. Okay. So, S here you will calculate in this form n 1 plus n 2 minus 2 S 1 square plus S 2 square. Like if we look into this question, a group of 5 patients treated with medicine A, weight 42, 39, 48, 60 and 41 kgs. Second group of 7 patients treated with the medicine B, weight 38, 42, 56, 64, 68, 69, 62 kgs. Do you agree with the claim that the medicine B increases the weight significantly? So, what is the situation here? What is the sample size of for medicine A? Sample size for medicine B. Medicine A sample size is 1, 2, 3, 4, 5. There are 5 samples in for medicine A. There are 7 samples for given it is 7 samples for medicine B. So, these are small samples. When these are small samples, you can calculate their averages can be calculated, and then their sample standard deviations can be calculated. For the first sample, the sample standard deviation you can calculate here x 1 bar minus x 1 for all the values whole square plus from every observation you subtract x, from all these observations you subtract x 2 bar, like we in general calculate variance. So, here you are trying to calculate that sample variance in both the cases, and that will result into S square. Use that S square value here and then calculate T cal. Once you have that T cal available, I hope you can do that yourself. T cal you will get it here. Use that T cal to compare with the tabulated value. Tabulated value would be at 5 degrees of freedom plus another 7 degrees of freedom minus 2 degrees of freedom. So, T at 10 degrees of freedom at 5% level. So, this is given T 5% at 10 degrees of freedom 2.23, T 10% at 10 degrees of freedom, it is 1.81. So, once you have the calculated value, you will compare that with the tabulated value, and then you can decide whether it falls in the acceptance region or it goes outside the acceptance region. Now, here the sample for medicine A is different from sample for medicine B. It is given the two samples in this test are independent. There can be a situation, suppose the 5 patients were given medicine A and also the same 5 patients were given medicine B at later stage. If it is say patient number P1 had certain increase due to the medicine A, say increase of 2 kgs, and due to medicine B later on increase of 3 kgs, right. So, it is the same patient, right. Then again second patient second increase, third patient third increase. If that is the case, patients are same, right, then that will come under a pair T test. So, you can have those pairs here, which is certainly not here because this is independent test. The last category of this is where we can have the pairs of samples. We will come to that also. Before that, we have one more example on difference of means. Like in this case, paired rating on 7-point interval scale under certain parameters of 2 cities, Delhi and Mumbai, whether those ratings are same for both the cities or there is any difference. So, you have separate set of consumers for city Delhi, separate set of consumers for city Mumbai, and whether the ratings are same or not, that we need to test. So, you can say mean ratings are same. Mean rating for your own product, not for the city, mean rating for your own product in Delhi and in Mumbai. How do they rate your product in these 2 cities? Mean rating in Delhi is equals to mean rating in Mumbai, then H1 mean rating in Delhi is not equals to mean rating in Mumbai. Now, here it is again important to understand that we are talking about whether the mean ratings are same or different. So, this will be one-tailed or two-tailed. This will be certainly, because you are interested in whether they are different or same. We are not interested in whether mean rating in Delhi is more than mean rating in Mumbai or whether mean rating in Mumbai is more than mean rating in Delhi. So, the only requirement is if the ratings are different. So, this will be a two-tailed test. In like in the last case, you can calculate T calculated, and here what is the sample size here in the both the cases? Sample size in the first it is 15, sample size in the second also 15. So, T calculated once you have, then T tabulated at 15 plus 15 13 minus 2 28 degrees of freedom. Tabulated you can check at this degree of freedom, this is 2.05. So, T calculated is greater than T critical alpha 5% level. So, H naught is rejected. So, you can say the consumer rate the product differently in 2 cities. So, your product is being rated differently in 2 cities. This we did in the beginning itself. In the center you have the acceptance region, and outside the boundary you have the rejection region. Rejection region in total we consider as alpha, our level of significance. Then when that is alpha, so half of that comes to one side, half of that comes to the another side, right. So, in this previous case, our T calculated is falling in the acceptance region or in the rejection region. T is greater than T alpha, na? T alpha are these values, this is T alpha, this is T alpha, In the previous case, see, if the value is 2.05, calculator is 2.75. So, when this is 2.05, 2.05 is here. So, 2.75, will it come to the right side or left side? 2.05, 2.75. When we go on the right side, then values increases, right. This is 0 here, on the left side the values are negative. So, 2.75 certainly will come in this red area with red lines. That is why in the rejection region. So, that is why we said that we are rejecting H naught. When we rejecting H naught, so that says the average rating of your product in two cities is not the same, right. And here are the tabulated values, T table we are given, like in this case when degrees of freedom were 15 plus 15. So, 15 plus 15 30 minus 2 n1 plus n2 minus 2 becomes 28. When you have 28 5 degrees, so this is 2.05, that is why we said T tabulated is 2.05. So, you can look at these values from 2.05 and be comfortable. How do we identify those critical values and how do we compare the critical values with the tabulated values. Then there is a software SPSS. If you open that, it looks like an Excel sheet. There are two views of it, data view and variable view. You can simply either copy paste your data into this, say this is the data of Delhi rating of your product, Bombay rating of your product, or you can from while going to this is just a snapshot. So, I cannot click and open the another things out of it, but whenever you will open this in SPSS, you can handle it accordingly. Then how to apply, I mean why we are discussing here, we are discussing for how to apply t-test or independent t-test or pair t-test. This you can go in by going into analyze, click analyze, then click compare means. Then if you have one sample t-test, independent sample t-test, paired sample t-test, here we were talking about independent sample t-test. Then under independent sample t-test, you can talk about the rating of test variable is what is the rating of Delhi and Mumbai. Then grouping, city grouping you can do as city Delhi and city Mumbai, which data is for city Delhi and which data is for city Mumbai, that you can click, and then that will give you automatically the T calculated and T tabulated value. Okay. So, using that, the moment you will click here and while clicking the option and OK button, that will give you the calculated tabulated value, and you can simply conclude whether the calculated is more than tabulated. So, manual calculation will not be needed here, right. Although obviously you will have to define yourself what is H naught, what is H1. But the results of the SPSS would be easier to find when your data is large or that the values are large. So, in this way we have covered the 6th test also, which is difference of mean under small sample tests. So, these 6 tests we have covered, these are all independent tests, and the next test under hypothesis testing would be the pair t test. Although all the procedures would be same, but the data may be little different, that will cover in the next interaction we have, right. So, thank you for your time.